this example, we're going to look at an application involving a quadratic function. We're going to use technology to graph that quadratic function, find some key features about it, and use those key features to answer a few questions about the function in context. Okay, so the problem that we're given says an object was launched from the top of a hill with an initial velocity of 160 feet per second. The height of the object h of t in feet can be modeled by h of t equal to negative 16t squared plus 160t plus 384, where t represents the number of seconds after the launch. Assume the object landed on the ground at sea level. Use technology to graph this function and answer the following. So the leading coefficient of this quadratic is negative, which means that it's going to open down and have a maximum. So it's asking us what's the maximum height of the object? When did this occur? So when we graph this, we should see a maximum point. We want to know what the initial height of the object was when it was launched, and also when did the object reach the ground. Okay, so let's go to Desmos and graph this function that we're given. Okay, so I'm going to graph h of t equal to negative 16t squared. Now, notice I'm not using x as my input. I'm using t, and it's still graphing this, right? So just something to note there. Desmos is really versatile that way. So negative 16t squared plus 160t plus 384. In this initial viewing window, we don't see much, right? And we need to set a window. So you can use the zoom features. If you're on a touchscreen device, you can use your fingers to adjust the window a little bit. But we need to see the vertex of this, right? We need to see the y-intercept. And by the way, the y-intercept often, most of these functions, it's pretty easy to determine in your head, right? Because the y-intercept in this case, it's when the input is 0. So what's h of 0? Well, it's 384, right? So you can manually set the window so that to adjust it to see something. You can also use these zoom features, right? So you could just say zoom out. Even one zooming out will do it. If you zoom out too much, I mean, like I keep doing this, and the two sides of this parabola get closer and closer together, but I'm still not seeing the vertex. So I'm going to zoom out a couple of pieces here, and this is an object that's being launched. I don't really need to see any of the negative x values, right? I kind of like to see the axes for myself, so I might set it at -2 for instance, just so I can see the axis, or even -1 would be fine. I know that I see this right now is set out at 20, and I already see the other side of the parabola. It probably wouldn't need to be that big. I could probably go to 15 or so and still see what I needed to see. And then the y-axis, again, I don't really need to see, I want to see the x-intercept, but I don't need to see too much on the negative end of things. So I don't know, -10 or so would probably be fine. But then the y value, the y-intercept is way up at 384, and that tells me that the vertex is even higher than that. So I might set the y max at maybe 500 or so. Okay, and I still don't see it, right? In that window. So maybe maybe even higher. We could go up to 700. Still not high enough. Okay, let's try 1,000. There we go. Okay, so there we see the vertex of the parabola. And we kind of barely see in that window the x-intercept. So I might extend the y-axis more in the negative direction just so I can see that more, maybe -100. And that way I see where it hits the x-axis. Okay, so anything to the left of the y-axis I don't really care about, right? I just want to know the object is launched here, right? So when we're talking about t equals 0, that's at the 0, 384, as we said, right? It reaches a maximum height here at 5,784. Okay, and then it hits the ground at 12, 0. Now, the other x-intercept of negative 2, 0 has no meaning in this case, right? So really, the part of this parabola we care about is when the object is launched, right? It follows this path, it reaches a maximum, and it comes back down here and hits the ground. So let's take this information and answer the questions that we were asked. So we were asked, what was the maximum height of the object and when did this occur? Okay, so first of all, we know what the maximum is and we need to take note of what the output and what the input represent. Okay, so the input represents the number of seconds after the launch, right? So that answers the question of when did it occur. And the maximum height itself is 784, right? The y value or the output there. And it's 784 feet, right? So we would say the maximum height of the object was 784 feet, which occurred 5 seconds after the launch. Okay. Now, what was the initial height of the object? Okay, so at the point at which it was launched, that was at t equals 0, right? At 0 seconds, how high was it? So that represents the y-intercept, right? And what is the y-intercept here? 0, 384. So the initial height of the object was 384 feet. Now, when did the object hit the ground? Well, if it was launched over here at the y-intercept, it's going to go up and come back down, and it's going to hit the ground when it's at 0 feet, right? When the output is 0. So that's at the x-intercept, and it's saying when did the object reach the ground? So I would say the object reached the ground in 12 seconds.